Hi everyone! In this tutorial I'm going to show you how to create a carpet bombing effect with Phoenix FD. So I'm using the latest version of Phoenix FD 2.2, and this is a shorter version of the tutorial. There is another longer video which is about 1 hour long, in which I explain in more detail why we are doing each of the steps and what could be the other results. So in this one I'm just going to lay out the scene and set the options, simulate and render, and show you the final results. So this one is for those of you who are more familiar with Phoenix FD. So we'll start off by creating our Phoenix simulator right here. So I'll make it wider and not so tall because we need a more spread out effect. I'm going to emit the explosion from a series of spheres. So their radiuses should be between 2.5 and 3.5. I will start with a medium one, and later I'm going to lay out the rest of them right here. So in order to emit with Phoenix FD, I will use the Phoenix source, which will feed this emitter geometry right here. We'll need to add it to the list of target objects. I will use the inject mode in order to get more of a blast effect. I will use the default temperature and the default smoke. This will be enough, and I'm going to animate the discharge of the source to just discharge a very high amount of temperature and smoke, 3000, just for a single frame, and then back to 0. Okay, so now we are ready to start our simulation, and it doesn't do anything because we have to add it to the exclude list of the simulator, otherwise it interacts with it, and the inject mode right here cannot work. It converts automatically to brush mode, which will feed more slowly the emitter. So here we are, we have our initial explosion. So in order to shape the explosion better, I will use the multipass method, which will give us more detail. I'm going to reduce the steps per frame to just one because we don't need more, and we're not doing a liquid simulation. I'm going to increase the conservation quality so that we have more symmetric explosions right here, and I'm going to use the symmetric method of conservation. Okay, so one more thing is I'm going to use the adaptive grid and set it to speed, and I will lower the simulator in order to fit the emitter inside it. Okay, so here it is, and it will start, the fireball will start expanding. No, so you can see here the adaptive grid has changed its shape. Alright, so one more thing is I'm using a 4-meter unit in order to get a more massive scale on the simulation. Also, in the dynamics tab, I will set the vorticity, I will lower it to 0.05, increase the cooling, and also introduce a bit of random noise. Alright, so next thing is I'm going to multiply our emitters. So I'm going to lay out other spheres as well. I will create a path for the explosion in the fashion that actually happens in real world carpet bombing. So I will make this a smaller one, then right here a bigger explosion. So the more variation you have, in the size of the sphere, which directly corresponds to the strength of the explosion. So the more variation you have in the size and in the placement and then in the timing of the explosion, I think the better effect you get, and it will be it will have a more of a violent effect to it. So this one will be a medium explosion, then a weaker one, and then maybe a couple of strong ones finishing off. Okay, so I will also bunch them more together in order to get more interference between them. Okay, like this. And whoops. And I will also make them more elliptical in order to shape the explosion better. Being more elliptical means that they will emit more in the up and down direction. And I also have to clone the Phoenix source as many times as we have the emitter geometries. Okay, so we got 6 and we have 2 more to go. Okay. And now we have to associate each of them with the correct geometry. Whoops. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Now, the next thing we need to do is to exclude these from interacting, as we did with the first one. So, in this way they will inject instead of brushing. And in this tutorial I'm going to also use a brush mode source in order to create the ground. So first off, I'm going to create a solid ground here. I'm not going to exclude this box from the simulator. I'm just going to lower it a bit and move it below the emitter sphere. So this way the explosion will interact with the ground and it will spread out wide on the surface, and it will also rise up, so it will have a more interesting and more realistic shape. And then the next thing I'm going to do is to create another box with which I will use the brush mode source. I'm just going to make it display as a box and not renderable. I'm going to use a brush source in order to create a thin layer of smoke on top of the solid ground, and this will help us get also more realistic effect on the simulation, and this way the explosions will interact with this smoke and they will draw it in as they rise up, and they will also create shock waves on it when at the moment of their explosion. So you will see the effect finally, and I think you will like it. So set the temperature to 300, which is in approximately in Kelvin. 300 degrees means neutral temperature. It's 0 Celsius, and the smoke will not rise, and it will not go down. And I will set the discharge to 100, because in brush mode this means percentage. So 100% means that we will just print the content of the simulator with 100% of this temperature and this smoke here. So I'm going to animate this in order to imprint it only for the first frame, and then set the discharge back to 0. Okay, so we can launch a control run of the simulation, we can see that this effect here, it happens because we have not excluded the brush box from interacting with the simulation. So okay, so right now it's better, but all of our explosions go off at the same time, so we're going to have to change their timing. So again, the more irregular the timing of the explosion is, of the explosions, the better. So I'll try to spread them out in more irregular fashion. Okay, I'll delay this one a bit, and okay, so let's see how this will do. So while the simulation carries on, I will show you the render settings that I prefer to use for this one. So first off, I'm going to set the smoke density to 0.9, and I'm using the simple smoke option because we don't need a more complicated transparency opacity diagram right here. The simple smoke will do. I just increased its opacity in order to get a more dense and more epic effect to the smoke. I will also change the smoke color to a bit more brownish, like this, and the effect of this will be a more red tint on the shading of the explosion. I will also use the analytic plus shadow scattering right here, and then I'm going to enable the emissive white and use the new grid-based self-shadowing that is introduced in the latest Phoenix 2.2. So the difference between it and the previous ray-traced self-shadowing is that the ray-traced self-shadowing produces naturally noise, and you need to wait a while for the noise to clear up. So the grid-based self-shadowing, it produces a result without any noise, and it works also a little bit faster than the ray-traced shadowing, but it shades only the content of the simulator itself. So in order to white up the surroundings of the container here, you still need to automatically use the Phoenix option to place either max whites or V-Ray whites inside of the simulator. So you have three options here. You have the simple placing, which is a spherical placing just around the hottest or the brightest actually part of the simulator. You have the inside placing, which is a smart placing and calculates where it needs to put the whites, and the problem with it is that if you are animating, and you may get some flickering because the positions of the whites are changing with each frame, and in order to cope with this problem, the new Phoenix now has the reduced grid white placing option, which will place the whites in actually a grid with a lower resolution. So here is the grid reduction. It will use by default 10% of the original grid. And this way there is no flickering, even with a more dense smoke, except in the cases where just your simulation flickers naturally. So I'm going to use this setup right now, and I'm going to just multiply the emission by 2. And okay, so that's it, and our simulation has finished. So the effect right now is different than the effect that we'll get if we increase the resolution. So I'll just increase it a bit, and then our final resolution will be with cell size about 0.26, which will be about 25 million cells. So when I increased right now you see the resolution with a couple of clicks here on the increase resolution button. Now we have a more proper shape of the explosion. Also, I'm sorry. I hope that this didn't distract the simulation. So I will also exclude the emitters from rendering. Okay. And now that we have enabled our whiting, we can see the result we get, but we will need to place some white source in our scene. I will just use a standard omni-white and put it right here on this end of the simulator. Okay, so when you're using whites with Phoenix FD, you have to enable them to cast shadows, and we will use ray trace shadows, and also I will enable the atmospheric shadows. Alright, so this way our smoke will act more naturally. Alright, and here it is. So I'm just going to check if I've excluded the correct box here from our settings. Okay. Alright, so I will just wait until the end of the simulation and then we'll continue. Alright, so here it is. This is our intermediate result with a medium resolution. So a couple of changes need to be made here. So first of all, I'm going to make, so let's just see it once again. I'm going to make the first explosion smaller because it pretty much steals the show. So I'm going to achieve this by just decreasing the radius. Okay, also I have to make the grid wider because it needs to fit all the action that's going on inside. So here it is. Up. Okay, and one more thing, I'm going to make the ground not renderable because it doesn't look good right now. Come on. And I'm going to prolong the animation to 200 frames. And that's it. I'm going to increase the resolution, simulate, render, and we are done. So this will be our final resolution, so we'll start from 30 million. Okay, and here we go. So our final simulation is complete and rendered, and there was just one option that I forgot to tell you to set earlier. Here the uniform density option should be checked, otherwise you get two round, two spherical explosions, and with this one the result will be better. So here is the final render. The simulation time was a little more than 4 hours, and the rendering time was about 5 hours on my Intel i7 CPU. So this is it, and I'd like to thank you for watching, and see you next time.